Hi, welcome to topic 11, Introduction to Probability. So in the next several topics, we would begin to talk about probabilities and something called counting principles, combination, and permutation. So let's do a quick introduction in this topic. So what is a probability? Probability is a measure of a random phenomenon that is likely to occur. Okay, probability is a measure of a random phenomenon that is likely to occur. So probability describes, okay, what we so-called the long-term proportion or percentage that a certain outcome will occur in situation with a short-term uncertainty. So think about this, okay? We all know when you flip a coin, okay, it's a 50-50 chance to get a head or a tail. However, that 50-50 chance actually is actually um, a long-term percentage, okay, then the outcome will occur. Okay, so here I have a quarter. I know you cannot see it. I'm gonna flip this 3 times. I'm gonna hit my table so you can hear it. I'm actually flipping. I got tails. Okay, so what am I gonna flip next? Okay, well, Mr. Chan, it's 50-50 chance to get a head or a tail. Well, we don't know. That's what it means by short-term uncertainty. In the short term, I don't know exactly what I'm gonna get. Okay, so I'm gonna flip again. And that's a tail again. All right, flip one more time. It's a head. Okay, so you see, it's not 50-50 chance to get heads and tails now out of the 3 flips. Okay, so the 50-50 chance is actually referring to as a long-term proportion. So that means if I will flip a coin 1,000 times, okay, the chance I'm getting a head and the tail or a tail is about 50-50. Okay, I should get about 550s. I mean, excuse me, 500 heads and 500 tails. Okay, so it's a long-term percentage with a short-term uncertainty. Okay, that's what I mean by that. That's what probability tells us. Okay, this concept called the law of large numbers. As the number of repetition of a probability experiment increases. So flip a coin 3 times, that's like an experiment. As the repetition of a random of a probability experiment increases, the proportion or percentage with which a certain outcome is observed will get closer and closer to the probability of the outcome. It will get closer to the true outcome. Okay, so every probability experiment, okay, there is actually a certain outcome will occur. We can actually calculate that. Okay, we can actually calculate that. But it's the short-term uncertainty is what makes, it's what makes probability fun, or you can say make gambling fun or playing cards, slots fun. Okay, but if you actually think about the long-term proportion percentage, the house always wins. Okay, it's a short-term uncertainty is what excites people, about playing cards, about playing cards, or any type of gambling, any type of those kind of game. Okay, remember they are games. But people take it a little bit too far, then it becomes habitual type of gambling. Okay, so as the law of large number tells us that as a number of repetition of a probability experiment increases, okay, then the proportion of a certain outcome will get closer and closer to the true probability of that outcome. Okay, a probability experiment, or sometimes we call them trials, is any process that can be repeated where the results are uncertain. Okay, that's a probability experiment where the results are uncertain. But as the trials or experiment increases, okay, you will actually get closer to the true probability of that experiment, of that outcome. All right, and the outcome is each individual result that is possible for probability experiments. Okay, was the outcome. So the outcome for the coin 3 times was a tail, tail, and a head. All right, sample space using calculator S. Sample space is the collection of all the possible outcomes. Earlier I said, things can be calculated, all right? A probability experiment can be calculated, so we know what the true probability is. Because the simple space, we can actually figure out the simple space of all the possible outcome in a probability experiment. Therefore, we can calculate the true outcome. An event is a subset of an outcome from the simple space. Okay, so event come from the simple space. So for example, consider the probability experiment of having 2 children. Okay, so think about this. Having 2 children, what could be the possible simple space? Okay, in how many different ways I can have 2 kids? Okay, a lot of students say, well, Mr. Chen, it's a 50-50 chance to get a boy. Okay, it's a 50-50 chance to get a boy or a girl. Well, that's for one child. That's for one child. Every child has two children. Okay, simple space. I'm using set notation. Is my first child can be a boy, my second child can be a boy. Okay. My first child can be a boy, my second child can be a girl. My first child can be a girl, my second child is a boy, or both my childs are girls. So your simple space, okay, is boy, 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 girl, girl, boy, girl, girl. So you got 4 possible outcome of having 2 children. Each children has 2 outcomes. Okay, so if you're having 1 child, the probability of getting a boy or a girl is 50%, half, right? But if you're having 2 children, okay, if you're having 2 children, then the probability of having both of them are boys is actually 1 out of 4 ways. Okay, so we're thinking about probability a little bit different. Okay, you got to think about probability a little bit different than what you normally think of. Okay, it's all based on the outcome, the total number of outcomes it can have. So let's define the event E as having 1 boy. So event E is having 1 boy, so that would be boy, girl. Right? That's the only event having 1 boy and the girl, boy. So the probability of having 1 boy, event E is defined as 1 boy. It's a subset of, the event is subset of this entire simple space. Okay, probability having 1 boy. How many ways I can have 1 boy for having 2 children? There's 2 ways, right? Boy, girl, girl, boy, out of 4 possible outcomes. So that's a 50% chance having 1 boy when you're having 2 kids. Okay, so it's a little bit different than what we normally think probability is. Okay. All right, let's take a look at types of probability. Subjective probability is an educated guess regarding to the chance that an event will occur. That's subjective. Okay. Now the 2 we're gonna focusing on, okay, it's called empirical probability and something called the classical probability. Empirical probability, or sometimes we call them experimental probability, uses the outcome obtained by repeatedly performing an experiment to calculate a probability. Okay, experimental probability is given, okay, if an event E, if E is an event, then probability of the event is given by the F means frequency. Sorry about it. F is the frequency that the event E occurs. N is a total number of times the experiment is performed. So we'll go by frequency divided by the total number experiment is performed. So for example, suppose you toss a coin 100 times, and out of the 100 times, you get 95 heads and 5 tails. Based on the results what is the estimated probability that the next flip will be in a head? Okay, so my event E is defined as flip ahead. So the probability of the next flip to be ahead got to be 95 out of 100. Okay, based on the experiment, the empirical probability is basically looking at, based on the experiment, the frequency of something occurred divided by the total number of experiment performed or the trials. All right, it's based on of the experiment. Now, the type that we're gonna kind of focus on, the type of probability we're gonna focus on is called the classical probability. Is the most precise type of probability and can only be calculated when all possible outcomes in a simple space are known. And more importantly, and they are equal likely to occur. You're gonna hear that wording a lot, equal likely to occur. Okay, in a classical probability, if all the outcomes are equal likely to occur, then probability of those events is given by, okay, n sub e. N sub e is a number of outcomes in the event, and n sub s is the number of outcome in the sample space. So we basically, what we're saying here is we go by the number of outcomes, okay? Number of outcomes, just like here, having two, define the event as having one boy. So the number of that event can occur is 2 out of 4 possible outcome in a sample space. So the denominator is a total number of possible outcomes in the sample space, okay? So you go by how many ways something can occur divided by the total number of outcomes. Okay, so the next few example is not hard. Okay, they're easy because I'm only picking one thing. So suppose there are 706 identical plastic chips, and that is numbered 1 through 176. Put it in the box. Okay, so inside this box, I have 706 identical chips, and they're all numbered 1 through 176. What is the probability of reaching into the box and randomly drawing a chip? Okay, I'm drawing one chip. And that number is smaller than 309. Okay, so my event is drawing a number that is smaller than 309. So I'm going to write it out. The probability of smaller than 309. Well, smaller than 309 means, that means 309 is not one of the chips you want to draw. So that means there are 308 possible chips, right? Because there are chips number 1 through 308. Okay, and those chips are one chips at a time, right? There's no two chips that are the same. So that means I have 308 ways to pick that chip smaller than 309 out of 706 possible chips, possible outcomes. Okay, so if I put that in the calculator, normally, in probability, we round the decimal to 4 places. If not, we will leave it as just like a fraction. So 4 decimal place, that will be 0.4363. So if you times 100, it's about 43.6% chance of drawing a chip that is smaller than 309. Okay, we're not saying there are 300, don't think of it like there are 308 chips in there. Think of there are 308 ways to pick a chip that is smaller than 309. Okay, out of 706 possible outcomes. their six-sided die is rolled, I'm rolling a die. What is the probability of rolling a number that is greater than or equal to 3? Okay, probability of greater than or equal to 3. Rolling a die, probability that is, what's probability of rolling a die that's greater than or equal to 3? So think about how many ways I can roll the die, or I can get greater than or equal to 3. Well, there's 3, there's 4, there's 5, there's 6, right? 6 sided, so there's no 7. So there are 4 ways I can win out of. I'm only rolling one die, so one die should only be 6 outcomes. So there are 4 ways to win out of 6 possible outcomes. Okay. It says do not simplify. We just leave it as 4 out of 6. It's about 66. It's about 2/3, which is 66.7% chance. Okay. So having a children and rope and flipping a coin is very similar because it's a similar experiment because the outcome, okay? It's because if you flip a coin, okay, a coin has one flip has 2 outcomes. Having one baby is 2 outcomes, boy or girl, right? So suppose a coin is tossed 8 times. What's the probability of getting all heads? All heads means 1, 2, 3, 4, 5, 6, 7, 8. That means every single flip is head. So there can only be one way to get all heads, right? Same thing with all tails. There can only be one way to get all of them are heads out of, well, what's the total possible outcome? There's only one way to get all heads out of, well, how many total number way there is? Well, every flip is every flip has 2 outcomes, right? Every flip has 2 outcomes. So if we multiply them together, that's the same thing as 2 to the 8 power. And 2 to the 8 power is 256. So in the calculator, 2 caret key exponent to the 8 power is 256. So that means there are 256 ways. Okay, excuse me, 256 total possible outcomes when you flip a coin 8 times. So flipping all heads is only one way on a 256 total. Reduction of probability kind of get you think about probability in a different sense. But it's not so much 50-50 chance, things like that. Think about how many ways you can win, okay, divided by the total number of outcome. All right. Question 1, 2, 3, 4, and 5 is coming from the definition. Okay, so just copy from the lecture handouts. Question number 6, I want you to, what's probability of rolling a number greater than 3? Be careful, greater than 3, not equal to 3. So the number of ways of winning is changed compared to the one I did just now. Okay, a coin tossed 9 times, what's the probability of getting all tails? Okay, try that one for me. Express your answer as a fraction. Do not simplify. Okay, you don't have to simplify your answer. Alrighty, so thank you so much for watching. Just real quick, a quick introduction on the probability. We'll talk more about probabilities in the next several topics. Thank you for watching.